Good evening, one and all. Welcome back to QCrete webinar series number 52. I am Anjali Pais, working as the technical coordinator with QCrete Readymix India Private Limited, and it's my honor to welcome the office bearers of ICI Kochi Center. First of all, I welcome Dr. Anil Joseph sir, the chairman of ICI Center Kochi. A hearty welcome to you, sir. Next is Dr. Elson John, the vice chairman. We welcome you, sir. Now next is Dr. Joe Thomas, the Secretary of ICI Center Kochi. A hearty welcome to you, sir. Next, let me welcome Dr. Sunita Nair, the Joint Secretary. We welcome you, Madam. Next is the Treasurer of Cochin ICI Center, Engineer Shaiju Nair, sir. We welcome you, sir. Once again, on behalf of QCrete Readymix India Private Limited, I welcome all the office bearers of ICI Cochin Center to this webinar session. Next, I would like to welcome the Managing Director of our company, Engineer Shelly S. Fernandez. Finally, let me welcome the speaker of this session, Engineer V.R. Kaushika, Director, QCrete Readymix India Private Limited. Now, handing over to Dr. Sunita Nair, Madam, for the welcome speech.
Thank you, Anjali. It gives me great pleasure to welcome all of you, all the eminent panelists who are here, the speaker, and the attendees for attending this webinar series that we have started. This is a series of webinars that will be conducted under the August of ICI Kochi chapter. I want to first welcome the speaker, Engineer V.R. Kaushika, and I want to thank him for giving this presentation to us, which will be very important because the one major limitation that we talk about in concrete is always the grayness of concrete. And today's webinar will possibly take away that issue of concrete being gray, and it will turn concrete to green. So thank you. As you all know, ICI has been in the forefront of developing the concrete construction in India, improving the quality, and the webinar series that we have planned will be conducted every month with eminent speakers. And now I hand over the session to Engineer Shelly Fernandez. Fernandez, sir, please, you can maybe introduce the webinar to the audience. Thank you.
Thank you, Sunita. Thank you very much. We from QCrete Readymix today is organizing a webinar series along with Indian Concrete Institute Cochin Center. And as you all know, we have been conducting this webinar for quite some time. We started this webinar series during the lockdown, the first lockdown, that is March 2020. We were all sitting idle in our house, nothing to do. Then that idea struck, might be Kaushika and myself thought that why can't we give something back to the society, or let us start imparting some knowledge, both from the academicians as well as from the people who have a lot of experience in various fields actually. And this webinar became a big success because sitting in your house, you can able to listen to experts speaking on various subjects actually. So it is a journey actually. It is a journey which we are carrying it forward actually. Even after the lockdown, we went on identifying good speakers. Some of the webinar series we had conducted through international speakers also. So we have quite a number of participants participating in these webinars right from all over the world actually. We can see the participants coming from UAE, Burma, all neighboring countries, even to the extent it goes to US also. So it is quite a success, and we conducting it as a series, picking up good speakers from across our nation actually, and coming and giving this beautiful sessions and sharing their experience, which is being now, we can see that range of people, participants, right from students to the academicians, to the people who are working in sites. It's benefiting everybody. That's what we could analyze from the participants actually. So with these words, we hope to continue and reach the QCrete webinar series up to 100 with associating with ICI Cochin Center. Thank you very much. Thank you.
Next, I would call Dr. Elson John to introduce the speaker to the audience. Elson, over to you.
Yeah. Good evening to all. So it's a very happy and proud moment for ICI Kochi to join hands with the QCrete for this webinar series. Always ICI Kochi and QCrete work hand in hand. Before the lockdown, we had a lot of offline programs on mixed design and content technology along with ICI Kochi and QCrete. Then now we are joining together for this very webinar series. So I thank personally to Engineer Shirley Fernandez, the founding president of ICI Kochi Center, for giving us all the support and advice for developing. So today, my responsibility to introduce the speaker of the day. So we have a eminent and wonderful speaker today, that is V.R. Kaushika. So he is in the field of construction field for almost more than 30 years, and he's an expert in many of the areas of construction and concrete technology. So the areas spread across as a strategist, business development leader, in general management, technical services of ready mix and construction chemicals, marketing and sales of construction chemicals and concrete. Is very good in leadership training, building teams, talent acquisition, customer relation management, quality control management, and in audits. So if I'm going to talk about him, it will take a lot of time. So I will just give you a small background of engineer V.R. Kaushika. So he completed his BE in civil engineering from PS College of Engineering, Mandya, in 1919, and later he completed his postgraduate program equivalent to MBA in business management from Alliance Business School, Bangalore. Later he undergone lots of training and certification programs just like concrete technology and construction in general practice and practical applications from City and Guilds Institute, London. Then is a lead auditor, completed the lead auditor course in ISO 9001. He trained in England in concrete technology and various aspects of ready mix concrete, participated in construction chemical product training program in Dubai, got trained in Italy and Slovenia on construction chemicals. He also got trained in Israel in the area of concrete technology. So he has a lot of certification programs and training in and abroad. He started his career as a site engineer in Property Development Corporation in 1990. Then application engineer in Foscock from 91 to 94. Then assistant manager, marketing and technical service in SN Supplements India Limited. Then territory manager in Warm Organic Chemicals, technical manager in RMC Ready Mix India, sales manager in again RMC India, concrete technologists in Master Builder Technologies in Saudi Arabia, QA QC manager in Al Turki Cements Limited in Oman, general manager in technical services in RMC India, and director marketing and technical services in ECMAS Construction Chemicals. And presently he is working as director QCrete Ready Mix India Private Limited and executive director in Amescrete Private Limited. So he has a lot of experience in and abroad. In addition to that, he has lots of publications about the concrete technology and construction in many of the national and international journals. So his experience is so vast. So I'm not extending because we are eagerly waiting to listen from him. So he's the right person for us to talk about introduction to green concrete, because he has a lot of experience in concrete technology and to make it green. And he's an excellent orator also. He has more than 150 technical sessions in last 10 years. So with this, I'm inviting Engineer VR Kaushika for this program. Thank you, sir. Please.
Good evening. Thanks, Dr. Elson John, for this introduction, and thanks to Dr. Sunita Nair and all office bearers of Cochin Center, and thanks to our MD Shalif Fernandez for this opportunity. I hope the screen is the PPT is visible. Anjali madam, PPT is visible?
Yes, sir. Yes, sir.
Yes,
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 sir.
sir.
It is visible.
Yeah. So I will go through this slightly in a different way. I will not jump into directly into what is green concrete. I'll just take a little longer route before we go into green concrete. So I just want to just share this information which is available, but just I'm talking about the mind-blowing numbers here, which is I can say we cannot even imagine the speeds that we are talking about here. So Earth is moving around the sun at a speed of 30 kilometers per second, and the sun is going towards center of galaxy somewhere 220 kilometers, and then the galaxies themselves are moving around 1000 kilometers per second. So this is extraordinary systems that we are living in, and you can see the unimaginable forces which are playing and controlling the entire cosmos. And what I want to tell you at this point of time is human beings, not even probably you cannot quantify the number at which level we are when we are talking about these huge cosmos. We don't understand the importance of these forces and try to play, try to disturb the environment, which is really causing catastrophes. We have seen many catastrophes, and many of the things are not recorded for last 40 years, and recently they have found a 8,000-year archaeological site in Saudi Arabia, which completely shifts the human civilization and the way it existed. We had until now 5,000, 6,000 years of history. Now they have found settlements in Saudi Arabia in middle of the desert in a place called Al-Fa, where they're talking about existence of irrigation and canal system, so which is unbelievable, which is the desert. We know Saudi Arabia as a desert, and there is no such kind of irrigation system possible, but it was there, and something happened. A small shift in the axis of Earth, or a small tilt in the way the Earth spins around the sun, or something like that has happened, which we don't know, has caused all this. So we are adding to this our own things in this unbelievable and unimaginable world. We are also trying to add our own bits into spoil the atmosphere, which is causing huge damage to the atmosphere. I'll just play. Normally I don't play videos, but this time I will just play this video before we go into green concrete. So we have seen the devastation, and the devastation is not only in that place. It is said that by 2050, many of the Latin American countries are completely will be not having food because the glaciers are completely drying out, and similar situations are going to prevail in many parts of the world because of the climate change and huge rise in temperature, which is happening because of the trapping of carbon dioxide, that is the greenhouse gas effect. So the greenhouse gases, predominantly carbon dioxide, is increasing around the world, rising the temperature across the globe, and very small changes, maybe 1 degree centigrade, 1.5 to 2 degrees centigrade, will have huge catastrophes, and the extent will be many of the coastal areas in India will be drowned if the situation doesn't is not addressed actually. So we have responsibility as civil engineers and concrete technologists, what we can contribute and in the construction field, especially in the concrete field, we should do at our best actually, because otherwise we'll be sending this planet to another disaster. So I will come to the definition of what is the green concrete here. Normally when we talk about green concrete, means it is unset concrete, or the concrete which is still wet actually. So we used to have these words that green stage wastage means in block factories and all, they say green stage breakages, green stage wastages when we are shifting blocks, concrete blocks from one place to another place. But this actual green thing was first initially introduced in terms of as a synonym to sustainability by Hans Carl von Kaldowitz. He made a simple rule that the trees should not be cut more than they are growing actually. So that is how he formulated this particular rule, and that is his concept of conservation. And then came this probably the most widely quoted definition of sustainable development, which was coined well-known Bertland report: the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So green concrete is one which is eco-friendly, where there is a usage of industrial waste, recycled materials, and which has a reduced impact on the environment. And the first concept, this concept itself was introduced by a Denmark person, Dr. W.G. So if you want to do green concrete, we need to be first aware of the materials that that help us to do green concrete. They can be classified into three categories. One is the very popular materials in India: fly ash, GGBS, microsilica. These products we have rice cash and even metacoiling. But generally in India, we talk about abundant usage of fly ash, GGBS, and then microsilicon. And then the next category of materials are the already used materials: post-consumer glass, recycled concrete, scrap tires, plastics, carpet fibers, and all kinds of fibers, and which can be used, fillers which can be used as in either cement or concrete, limestone filler. Cement is done added with 10 to 15% with limestone powder. That is also comes in this category. So generally these materials are waste products or byproducts of other streams And generally in India, the usage of this category of materials is very limited at this moment, but sooner or later it is going to pick up. The third category is a big category that is already being in use in India. It consists of materials which help us to reduce the cement consumption or increase the strength or add some properties to concrete. Like we have admixtures which help us to transport the concrete, which alters the setting time of concrete and which adds many other properties to concrete. And we have other materials. One of the novel additives are there which help in reduction of cement content, which is commercially known as iQcrete. These kind of products which help us to make better mix designs when compared to the reference concrete mixes. And then there are other materials which can be added to increase the thermal conductivity. And then many other materials are available like carbon nanotubes, graphene oxide and all these products which can also help to improve the properties of concrete. And there are other technologies now where we are talking about the curing of concrete by using carbon dioxide. One of the companies, Carbon Cure, is making that one. And these are the third category of materials. So the different categories of materials can be combined and effectively harnessed to make green concrete. The aim of green concrete is to reduce environmental impact of concrete, basically. And together with this, when the designer starts trying to do green concrete, he takes help from structural design specification, manufacturing, maintenance, includes all aspects of performance, where there is a consideration of mechanical properties, fire resistance of the material, workmanship, durability, thermodynamic properties, and most importantly, environmental impact. So all these are considered, and especially durability is one of the major aspects of green concrete. So when we are talking about green concrete, as we said earlier, we also go with the other term called sustainability, as we all know, meeting the needs of the present generation without compromising the ability of future generation to meet their needs. So anything that we do today should not be depriving the future generations from getting the similar materials at approximately similar costs. For example, we are using concrete or cement now. For example, let us say in 50 years time, the cement costs 15 times or 20 times the present cement. So that becomes a costly affair, and it discourages the usage of cement itself. So that becomes unsustainable. So American Indian proverb says, treat the earth well. We do not inherit the earth from the ancestors. We borrow it from the children or from our children. A beautiful proverb which goes on to say a big emphasis on the type of usage that we have to do with respect to natural resources. Of course, in India, 5,000 years back, there is a lot of literature written where it talks about do not cut the trees because they remove pollution, do not disturb the sky, and do not pollute the atmosphere. So this kind of literature is already available in India. But we know, when a scientist looking through his telescope says there are 300 billion stars in a distant galaxy, we believe the scientist. But when another person says that the chair near you is painted and it is still wet, don't touch it. So we try to touch it, and we don't believe what he says, but we try to test ourselves. So what happens in our backyard probably we don't easily take that as important. We generally believe what somebody else tells, probably sitting about 4,000, 5,000 kilometers away. So anyway, we know that these concepts have been rooted in Indian civilization also, and Indians were really far ahead in this kind of natural conservation of the entire organisms and the eco-friendly atmosphere. So most recognized sustainability programs primarily focus on energy conservation, atmosphere, water quality and resources, site selection and development, indoor environmental quality, material quality and resource. It is the above complex relationships that present challenges for the achieving greater sustainability. So in terms of construction materials, whether it is concrete or any construction material, production of construction material, then construction, life cycle and demolition. So figure shows various stages of construction materials. Any type of construction material is produced with some raw materials or combination of raw materials, and production is associated with the consumption of energy and releasing some quantity of waste. Therefore, production phase is important to consider while we deal with environmental impact. There are various questions which give rise in the production phase, such as, are the resources renewable? Are they important to environment? How much energy will be spent on the production? So these questions are important, and this phase probably receives more attention from public as well as from the government. So two important concepts of sustainable development: meeting the essential needs of the world's inhabitants and recognizing the limitations of technology and society's ability to meet present and future needs. So a sustainable development, including construction and concrete, should consider how land is used, water is used, atmosphere, judicious usage of material sources, indoor environment and work environment. For example, concrete, every cubic meter of concrete, we use about 180 liters of water. For curing also we use water. This is a huge activity for curing and for production of concrete. And in fact, in ready-mix companies, many ready-mix companies, even though they have started recycling the wastewater after cleaning the trucks, which is a very good development, even still today, many of the ready-mix companies have the habit of using fresh water for washing the trucks. So usage of water is going on unabated without any hindrance. We have to know here that only 4% of the total water available on this planet is fresh water, and in that 4%, we have some of the water locked in glaciers and icebergs, and also some of it is locked on the Earth's crust. And if we are wasting for non-productive works, it is going to cause huge problems, as we have seen in the video. Like, you know, in many places where there was plenty of water, drinking water or water for basic consumption of human beings or other species will not be there, and we are going to enter into huge problems. We may be knowing, many of us, like, you know, I've seen a river in our childhood where we were fearing to go near the river, but now river is almost missing. Actually, means river has shrunk. The total amount of water which flows has completely drained, and there is no, we cannot say it is river. So there are many places, many rivers where the water is completely not there, and rivers are missing actually in action. So similarly, if we don't restrict the usage of water, whether it is concrete curing, whether it is concrete production, to limited levels, then we are going to have unsustainable or non-greener concretes. Having said all this, concrete is still a wonderful material. Its impact is least when compared to steel and wood. So if somebody is constructing a building just because he wants to construct quickly for the convenience, the impact they are causing on the environment is higher than a concrete or concrete built or a mud built home. So here we see even though the cement and concrete has least impact on the total environment when compared to other activities of human beings like transport and operation of buildings, etc. Still, we have something to control. We can control what we can control as civil engineers and concrete technologists. So we have to focus on this cement and concrete. So what is the problem with the concrete? Concrete is has the problems are rooted with the manufacturing of cement, metal acquisitions, and use of water. As we said earlier, use of water and then cement. If we are manufacturing 1 ton of cement, we need 1.55 or 1.6 tons of limestone. It has to be quarried, it has to be transported, it has to be crushed. And this is a very energy intensive process. And the next point is the OPC. As we are manufacturing, it generates about 800 to 900 kg per ton of cement manufactured. And then OPC is the one material which is synthetic product in the concrete, and it tends to go back to its natural state. So limiting the OPC is prudent and important because in that way you are increasing the stable components of concrete. And we also know that cement, if we are increasing the consumption in concrete, every 100 kgs of cement increased in the concrete per cubic meter will give rise to a temperature rise of about 11 degrees to 13 degrees, which will increase the core temperature of concrete, and the temperatural differential, if it goes beyond 13 to 15 degrees, thermal cracks will be there in the body of concrete, which will make the concrete deteriorate faster or undurable. The other one aspect of OPC production is, we have seen over the years that it is not the cement content which is important, it is the water cement ratio which is important. So at lower water cement ratio, by judicious mix designs, we can get the strengths that we want, and the modern admixtures that we have today have been able to have pushed the water cement ratios easily to a level of 0.22, 0.23 and things like that. And hence, at lower cement contents, we can get higher strengths and higher durability. There's no problem with that. So we should be concentrating on the lesser usage of OPC. So we can see here 6% of carbon dioxide emissions from global cement production, which is huge in that way. Aggregates, sand, huge mining, crushing, transportation. Billions of tons of aggregates are crushed, transported for making concrete every year, and so this is not a small thing actually. So entire, earlier sand mafia and dredging of sand have changed the paths of rivers actually. Means many times it has completely disturbed many areas environment. Now thanks to the introduction of so-called manufactured sand or the crushed rock fines, which is a kind of a byproduct from the stone industry or the crushed rock industry. So we have a better situation. We are moving towards more sustainable concretes due to the 3-stage VSI crushers, etc., where judiciously good graded sands based on the crushed rocks are coming out. And as we already discussed, water we are using in big quantities for mixing, cleaning, and curing. So one of the authors, I have forgotten the name, he says 50 billion tons of aggregate is pressed and then transported, and it is enough to make a blanket on the entire United Kingdom. So sand is also being used for making glass, which is another important material in the construction industry. So together, manufacturing of glass and manufacturing of concrete constitutes huge portion of usage of sand, and then which is environmentally bad. So what is the green approach? The green approach is to become environmentally responsible and make better concrete production systems, minimize emissions and waste, improve energy efficiency, ensure excellent product quality. So by having a complete control on the mix design and then water cement ratio and usage of good materials, including SCMs, we can ensure better quality, and we can reduce the emissions also. So reduce the concrete usage by reduction of thickness of members, use less binder material, especially OPC, as we have discussed, use supplementary cementitious materials, use high performance chemical admixtures. And the scope in India is huge actually, because India is second largest manufacturer of cement in the world after China, and then the ready-mix concrete is still growing faster, and we have the infrastructure, huge projects coming up in infrastructure and other segments of concrete industry. And being concrete technologies, we can utilize the experience and the knowledge to make greener concrete and make a positive impact on the environment. And one of the most significant contribution, I can say, by the ready-mix industry in India is starting from I can say 2000 to 2022, last 15-20 years, there is a good increase in the usage of pozzolanic materials, especially fly ash and GGBS. You can see most of the ready-mix companies either using GGBS or fly ash, and we have the modern concretes which have been absorbed by the ready-mix concrete industry, and which is having a positive impact on the rate of construction and quality of construction. There also there is a significant usage of the industrial waste like fly ash and GGBS. And use of pozzolanas, as it is, it goes without saying, to make durable concrete, how this pozzolanas or pozzolanic materials are contributed. And this is a basic microscopic structure of different materials: fly ash, Portland cement, and slag. What I want to bring to the attention here is the fly ash particles are spherical in nature. When the particles are spherical, it gives better workability, and it is said that if we are replacing by about 25% a good quality fly ash from a mix in a mix, it gives a water reduction of 6% to 8%. So when this water reduction happens, automatically the durability and other properties will increase. We have seen huge usage of fly ash and GGBS, and the contribution to the concrete industry by these two materials, apart from making the concrete greener, is that the setting time is better. I mean to say setting time is longer, which allows the user and concrete producer to use the concrete for longer period and transport the concrete for longer distances. Bleed rates and other things are improved, cohesion is improved, workability of most of these materials, when we are especially about fly ash, is significantly improved, and the pumpability is improved. Silica fume in this direction, silica fume is a killer of slump. It means it reduces the slump, but of course you can compensate that with usage of better admixture or higher dosage of admixture. Pumpability and finishability is definitely better, and hence it goes without saying that the cover concrete means the cover concrete becomes more denser if the finish is good, and hence the chlorides and sulfates cannot easily penetrate when the finish is done well, or if the finish is having a lot of blemishes like crevices and all, the chloride sulfates can enter. So the concrete cover becomes denser, better. And this is one of the favorites that we always talk about, the strength. So OPC is a dead horse after 28 days, means it will not gain the strength after 28 days much. But when you are blending OPC with GGBS or fly ash, the curve goes up actually, and this is a significant contribution in terms of higher strengths at later ages. So the OPC cannot match with this supplementary cementitious blended concretes. Some of the researchers have found that when concrete is blended with 50-60% of GGBS, the strength levels have doubled in 10 to 12 years. Okay, so a customer theoretically who has got a 30 MPa concrete probably will end up with a 45 or 50 MPa based on the type of reaction and the type of the materials and the reactivity of both GGBS and OPC. He may end up with a M50 concrete at the end of maybe 10 years or something like that. So this is a huge contribution in terms of strength, and we'll come back to the durability later. So this was one of the cubes cast on site, on a church site in Chennai, and we can see the jump between 28 days to 365 days, which is it has jumped from 37 to 55 MPa. This is fly ash from Ennur near Chennai. Several, I can say thousands of results. Each result is an average of 3 cubes was taken from Coimbatore, the fly ash from Tuticorin, and several brands of cement, and we can see a significant jump of 40% between 28 days to 90 days. So temperature rise is less when you are using GGBS or fly ash. GGBS lowers peak and overall heat, reduces thermal stress, reduces micro cracking. Optimum substitution is 60 to 70%. You know, IS code permits usage of GGBS between 25 to 70%. But there are many people in India, many projects where they use 10%, 5%. So if we use very less amount of this material just for the sake of use, it will not enhance the performance. And on the other hand, if there is a problem with cement itself, a quality problem with cement, so it adds to the problems actually. So it doesn't give any result if you are adding at a very low dosage. So we need to add at approximately 35 to 50% if you are trying to get good performance. I'm talking about GGBS. So in terms of heat of hydration, then when you are having a 70% or 50% GGBS, there is a tremendous reduction in the heat generated, which will help for the containing of the total heat generated in the initial stages and then enhancing the durability eventually. So sulfate resistance is another aspect which is significantly improved by addition of pozzolanic materials. We can see here fly ash addition of 40 to 20% against the general purpose, that is normal cement, where we have here it is almost going parallel to the x-axis, means expansion is less, expansion is maximum when you're talking about the OPC. So resistance to sulfates is enhanced, resistance to chlorides is enhanced. We can see here when you're adding 60% of GGBS, there is no chlorides penetrated at a depth of 25 mm in a concrete system. So resistance to chloride, another slide which talks about time to corrosion initiation. Time to corrosion initiation, when 60% is added, it takes 70 years for corrosion initiation. Whereas if there is 100% OPC, we have very quick initiation of within about 10 to 12 years, and time of first repair is here. So what is it? What is this important thing? What we are talking about is here. When we are making green concrete using GGBS or fly ash, the durability is enhanced. You have long-lasting structures, and hence you need not have to repair. You need not have to invest on again bringing new materials or new raw materials and new cement, things like that for construction, and hence your overall sustainability is improved, durability is improved. So it is estimated, for example, in many countries there is a huge cost is waiting actually. For example, in India also, as the bridges and infrastructure gets older and older, and if there is gross negligence exhibited in these areas during the time of construction, and if the materials were not used properly, and if some of these materials, SCMs, especially GGBS or fly ash, is not used in right quantity, the repairs will come very faster, and the repair costs are huge, and it is going to have huge impact on the national economy. So as a part of sustainability, as a part of sustainable construction, we are supposed to use these materials judiciously to push the durability to better frontiers, and hence get the most of it. Another slide showing about the diffusivity of chloride when at 60 to 80%, between when the increased usage of GGBS between 60 to 80%, you can see the diffusivity is almost nil. Professor Anand Swamy says there is a tremendous improvement in permeability, and and the reduction is almost 56% when 50% GGBS is used actually. So there is a tremendous possibility of enhancing the durability when you are using fly ash or GGBS. Professor Dr. Bhattacharya of IIT has talked about the service life with respect to chloride attack. So if the chloride attack happens, what happens to the different materials used actually? If the concrete is made with only OPC, and you can compare that with the PSC, there is a comparison. So different materials, as we discussed earlier, microsilica, metakaolin, fly ash, can be used to make a highly durable concrete. RCPT values below 500 represents high durable concrete in a chloride environment like coastal areas. So you can push the concrete to higher durability by using these kind of materials. And an example is given. Let us say we have given we are doing OPC plus GGBS mix 50%, 50%. So this is they have calculated that it is equivalent to not driving car for almost 92,000 kilometers. So this is how they have calculated. Means if we do such mixes wherever possible, and if we try to change the specification, if we convince the specifiers to use GGBS, so we can contribute to the carbon dioxide emissions in a big way. Another positive impact of usage of GGBS or even fly ash to a great extent is that if it is lighter, the contribution in terms of the reflectivity of light, this is represented by albedo value. It is said that snow has a value of 0.9%, 0.9, and black paint is having a albedo number of 0.05. Means black paint absorbs most of the light. So if you have a GGBS concrete 50%, so the albedo number is 0.5. Means reflection will be better. People can see visibility is better for longer distances, and then lighting is reduced. You don't require much lighting. This means you can reduce the amount of energy that is consumed for lighting or something like that. So this is an additional impact, and this is an additional effect of using these materials, which again goes into help to make the concrete and construction greener. So in short, benefits of mineral admixtures: good workability, better cohesion, finishability, increased strength, reduced permeability, increased resistance to chlorides and sulfates, control of alkali silica reactivity, increased overall durability, architecturally appealing light color concretes. If you are using metakaolin and such materials, reduces efflorescence, improves aesthetic values, reduce rebound loss when we use metakaolin in terms of shortcutting and things like that, can be used for enhancing properties of concrete with SCMs. So if we compared different materials, so what is the energy used for production and transportation? Embodied energy means what is the energy used for production and transportation. So we can see if we are transporting any of these materials, it is around 175 to 100, and we can see here aluminum has higher embodied energy during production when compared to Portland cement. So when we are using, with all the people blaming concrete and cement, still cement is a good material that we have to do. And we told negative things about OPC. The positive things as on today is also there. The positive things about OPC is that quicker construction, quicker stripping of the side shuttering and things like that. OPC is still head and shoulders above, unless otherwise you are using a very advanced admixture with a certain percentage of SCM. So still OPC is a winner in some cases, not bad. But overall, if you want to push the durability and make greener concrete, we have to be moving away from OPC. Still, some people are hanging on to this because lack of awareness in terms of usage and lack of awareness in terms of available materials and mix designs. So what is the carbon dioxide reductions that are possible if we are using SCMs? So a 335 kg mix with 0 kg of fly ash or 0 kg of GGBS. In this, the carbon dioxide emissions is 303 kg per meter cube. And if we go to 282 kgs of cement and 94 kgs of fly ash, it comes down from 313 kg per cubic meter to 160 kg per cubic meter. And when we go to same mix, let us say here 376 kgs of OPC, now 188 OPC, 188 GGBS, it has come from 211 to 112, almost 50% reduction in the carbon dioxide emissions. So if we can shift from one mix to another, we are moving significantly up and making better, greener concrete. Suitability of green concrete in structures reduce the dead load of structures because the density of concrete made with SCM is slightly lesser when compared to concretes made with OPC. A reduction of emissions by 30 to we saw 50%. Okay, let us say 30%. Increase concrete industries usage of waste products by 20%. Good thermal and fire resistance when compared to traditional concrete. Means improvement in permeability and usage of new types of residual products, like you have red mud, so many other products. And I want to just talk about a little about usage of recycled aggregates here. Recycled aggregates have not picked up so well in India. In other countries, recycled aggregates and recycled fine aggregate from the building waste is being used successfully, especially in countries like Japan. They use a huge amount of this building waste to be incorporated in their concrete. The problem with the usage of recycled coarse aggregate and recycled fine aggregate is it also comes with some of the other building waste, like probably gypsum and paint, etc. So all this putting into concrete, it will not give similar strengths or better strengths, and it has to be added in a controlled way. Even though we can classify this as greener concrete, it many times becomes costlier because the building waste have to be transported to a crusher and then crushed, which many times collection, transportation, crushing, all this will take some time. So the other problem with recycled coarse aggregate and recycled fine aggregate is more higher porosity and absorption. So this makes its utilization, it limits its utilization and usage beyond 20-25% or 40% is undesirable. It will give undesirable effects. So having said this, the recycled coarse aggregates and recycled fine aggregates definitely will find a place, because billions of tons of building waste are being dumped as landfills, which is they say what is called as downscaling. It is not upscaling, it is downscaling. So that goes as a waste actually. It means what you can fill up completely with an unusable material, that is okay. But if you can upscale, means you can upgrade a material and use it for construction instead of taking out virgin materials, means by quarrying and crushing, that will be a better idea. So coming back to suitability, it requires less maintenance and repairs. Compressive strength behavior of concrete with water cement ratio is more than that of conventional concrete many times. Fractional strength of the green concrete is almost same. Carbon dioxide neutral waste derived fuels shall substitute fossil fuels in the cement production by at least 10%. Use of concrete industries own residual product. In a way, ready-mix concrete has contributed well. Many companies are using 25% to 50%, sometimes 100% of the wastewater generated to be incorporated back to the concrete. So So greening of concrete is going full swing. List of 4 benefits of using green concrete. So it lasts longer. Many times the resistance to fire is more, lower rate of shrinkage. All of these factors add up to a building that will last longer than one made with ordinary concrete. Similar concrete mixtures have been found in ancient Roman structures, and this material was also used in Ukraine. Industrial waste, which otherwise will be dumped into the landfills and all, are being used better. Earlier, we used to see mountains of slag near a steel plant. Now we don't see, because it is effectively used for manufacturing of GGBS and being used. Hundreds of thousands of acres of land are used to dispose of fly ash. A large increase in the usage of green concrete in construction will provide a way to use up fly ash and hopefully free many acres of land. Reduces energy consumption because of the better finish, better cohesive nature of the concrete. The materials that are used in Portland cement require huge amounts of coal and natural gas to heat it up to the appropriate temperature to turn them into Portland cement. Fly ash already exists as a byproduct of another industrial process, so you are not expending much more energy to use it to create green concrete. Another way that green concrete reduces energy consumption is that a building constructed from it is more resistant to temperature changes. An architect can use this and design a green concrete building to use energy for cooling, heating and cooling more efficiently. Reduces carbon dioxide emissions, which we already discussed actually. There are cases where a huge amount of GGBS and recycled aggregates and wastewater, limestone filler along with cement has been used to make low carbon concrete, or even now the carbon capture technology, where carbon dioxide is pushed into concrete to cure. Carbon cure technologies are available, which all make a reduction, huge reductions in the carbon dioxide emissions, and hence make the concrete more greener and have a very positive impact on the planet Earth. So thank you. This is a brief introduction to green concrete, and I'm thankful to ICI Kochi chapter, and then I'm thankful to QCrete Remix India MD and other organizers for giving me this opportunity. And I hope the audience who have come late in the evening will have benefited from the experience or some words shared here. Thank you.
Thank you so much, sir. Sir, we have got a few questions and I'll read out one by one so that you can answer them. Okay, the first question is how does excess water leads to crack in concrete? How to reduce bug holes in SCC concrete? And that was asked by Krishna Rathod.
Once again, madam, can you please repeat the question once again?
Sure, sir. Sure, sir. How does excess water leads to cracks in concrete? How to reduce bug holes in SCC concrete?
Excess water in concrete. Scientists have found long back that you require 0.22 to 0.27 as a water cement ratio for cement to undergo hydration. So anything else extra we are adding, it means that we are adding water for convenience of better slump and transportation. And hence, when you are adding more water, if you are adding more water, that more water, instead of participating in the cement hydration, is evaporating. So more the water, more the opportunity in the initial stages itself to escape from the concrete surface, and when something escapes out of the concrete surface, the gap created is a crack. So more water you put into the body of concrete than required, more than the optimized level of water cement ratio, that you are giving more opportunity for water to escape. So if you put more water, and if there is a more ambient temperature and higher winds, it will take more water out of the body of concrete, and hence there will be something missing out of the concrete, and that missing is expressed as crack. And the other question, what is the other question, madam? Bug holes. Bug holes is bug holes minimizing requires proper compaction, better shuttering oil, good shuttering oil, and another thing is, many times if you take a very compact shuttering, and if you speedily fill up concrete, the air voids, air doesn't have time to escape. It will be expressed as bug holes. So rate of pouring, height of pouring, quality of shuttering, quality of the shuttering oil or mold release agent, and for example, if you are holding the truck for a long time, many times the air content in the mix is reduced. But if you are pushing the concrete very fast, as soon as the truck comes to the site, it may lead to bug holes. So there are many reasons, and it is to be decided, or it has to be solved on site.
Okay,
Okay,
thank
madam.
you, sir. Yes, sir. Thank you, sir. Next, we have a question asked by Mr. Kamisheti Nikhilesh. And the question is, what is sequestration of carbon and what they will do?
Sequestration is means taking out of carbon dioxide from the atmosphere. Okay, so one of the ways is you have this normal, for example, concrete blocks you are making. You collect the industrial carbon dioxide from thermal power plants or any place where there is a emission of carbon dioxide, and then you pump it into concrete. So the concrete, in the concrete, when the initial reaction is taking place between the calcium silicate hydrogel and calcium hydroxide is formed, this calcium hydroxide absorbs the carbon dioxide and forms calcium carbonate and reduces the outside carbon dioxide. Means this is called usage of carbon dioxide from outside, or sequestration. So these kind of concretes are called as low carbon concretes. And you know, when you're using high amounts of GGBS, also it is called low carbon concretes. And if you cure using this kind of technology, that is also called, that also adds to the total amount of carbon dioxide in the life cycle analysis. For example, if you are talking about life cycle analysis of concrete, that is from the production stage to the plant, ready-mix plant or plant where the concrete is produced, until how the concrete is used and how this concrete is recycled or not. All this will form the life cycle analysis of concrete. So in this entire life cycle, what are the activities done and how much carbon dioxide is and energy is generated, all are put together, and it is classified as low carbon or normal concrete. So this is one of the methods. Yeah.
Thank you so much, sir. Next question is it possible to use GGBS, microsilica and fly ash with PPC cement? Please let me know how much cement percentage we can replace with PPC cement. And that was asked by Mr. Dilip Kumar.
So PPC cement, that itself means it contains OPC and some amount of fly ash. Generally, cement companies may be adding between 15 to 35%, something like that. Some companies will add 25 based on their the way they give the properties of cement. So if you are adding additionally fly ash from outside, you should know how much they have already added, and then you have to add. So if they have already added 15% to make PPC, as per code provisions of India, you can add another 20%. So we should know how much they have already added. On the other hand, you can also add GGBS. It will become kind of a composite concrete or composite cement. And again, here also we should know what is the percentage that they have added, because too much addition of external GGBS or fly ash, even though it will give a durable concrete and the long-term strengths are better, everything, it will affect the setting time, and these setting and other initial early stage properties are affected. So we can add fly ash or GGBS with microsilica, but we should know how much the cement company has already added. Yes, thank you, madam.
Thank you so much, sir. Next, we have a question asked by Dr. B. Kamesh Rao. And the question is, why we use lesser percentage of pozzolana in PPC, which is 15 to 35%, compared to slag in PSC, which is 25 to 70%.
This is as per the codal provisions. So in PPC, the codal provisions is fly ash can be used between 15 to 35%, and we know it can be used between 25 to 70% in terms of GGBS. Whereas in other countries, there are different kinds of cements allowing higher additions of fly ash and GGBS, specially designed for different applications. In India, we don't have higher additions allowed actually. So that is why mostly they use lesser. And in another, in many other companies in India also want to use lesser amount of fly ash, because many times the customers are comparing the fresh properties, especially the set time and deshuttering time, against the already being used reference concrete, which is concrete made with OPC. So the when they're using fly ash and GGBS, if the customer accepts slightly delayed setting and all, that will allow a manufacturer, either a concrete producer or a cement producer, to add more. But many times, since it is going to various customer segments, including retail market and industrial segment, they want to play safe and they want to use as lesser dosage of these materials as possible, so that the setting time is not affected and the initial 1 day and 3 days are not affected actually. I think Dr. Rao, I think answered you, sir. Thank you.
Thank you so much, sir. The next question is, why is fly ash suitable in construction of multi-storied buildings? And that was asked by Mr. Sheikh Rukshad.
Fly ash is suitable in all constructions, all kinds of constructions, whether it is multi-storied or a dam or road or anything actually. Only thing we need to be aware when you're using fly ash in higher percentages is, when you are adding fly ash, the initial strength gain up to 7 days is slightly lower when compared to OPCs. And since the reactions between OPC and fly ash is means there is a secondary reaction going on, and the reactions are continuous, longer than what happens in a traditional OPC concrete, the curing time has to be increased. We need to cure more when you are using fly ash concrete, but definitely it can be used in all kinds of constructions with proper care and proper mix design to get desired and excellent benefits. And the durability can be, if judiciously used, much higher when compared to normal ordinary concrete. And ordinary concrete, in fact, cannot compete with OPC fly ash concrete in many aspects, especially in terms of durability and other properties. Thank you.
Thank you so much, sir. The next question is asked by Mr. Vikrant Sonar, and the question is: in GGBS mixed concrete, sometimes mixed concrete, sometimes admixture dosage needs to be decreased and slump retention is also more. How to tackle this situation at RMC supplies?
So there is a fundamental basic principle which we have to understand actually. In the water demand is in the descending order as we are going from OPC towards fly ash or GGBS. You can say OPC, for example, you have 180 liters of water for a certain slump. If you are adding OPC plus GGBS, it will require lesser water, and OPC PFA will require much lesser water. So if you are shifting from OPC to GGBS and OPC GGBS to OPC PFA, the water content goes in descending order. And in the same way, the admixture content also goes in the descending order for the same slump. So if we use the same dosage of admixture, like we are using OPC, or let us say somebody was using a dosage of 0.6% to get a certain slump of say 120 mm after 1 hour, and he increases the GGBS content to 50%. So 30% GGBS to 50%. When the SCM content has gone up, the water demand goes down. If the water demand is kept same, then the admixture demand will go down. So admixture has to be used as less as possible. Slump retention is normally either equal or better when you are using SCMs, whether it is GGBS or fly ash. Fly ash is best in terms of slump retention and the dosage of admixture, etc. But GGBS is also not far away. I hope I have answered.
Thank you, sir. The next question is: how much percentage green concrete is used in developed countries? And that was asked by Mr. Naresh.
We can say at this moment it can be anywhere between 50 to 60% or up to 70% in developed countries. It is slightly lesser, but thanks to the in India, thanks to the ready-mix companies, I can say ready-mix companies in India itself, if you are taking ready-mix concrete segment, we can say 50 to 60% of ready-mix concrete production is green concrete in a way. Yes.
Thank you, sir. Next question is: for precasting, early strength is required and hence OPC is preferred. If we want to use GGBS instead, how to take care of early strength? And that was asked by Venkataramana Katinakare.
As I said earlier, everybody dislikes OPC and it has a lot of problems actually. But one undeniable benefit of OPC is the early strength. Having said this one, now modern admixtures, PC-based admixtures, very good admixtures are available, where by judicially adding certain amounts of GGBS and reducing the water solvent ratio by using high range water reducers, or I can say hyperplasticizers, means which give a 30% to 40% of water reduction. That kind of PC based admixtures are available, which are specially formulated to give early strength. By using that, you can use GGBS or even fly ash to come closer to OPC strengths, and you can have probably a greener or better or sustainable concrete even in precast section. As I said, we have materials like QCrete, which is a novel additive for making cement reductions. So that kind of material also is available. by using which you can reduce the cementing content or cementitious content, also increase the SCMs. So now technologies are available. Only thing is we need to be pursuing, and we need to be patient. Maybe in one trial or two trials it may not come. We have to continue for some time until we reach the point where we can use these SCMs in a good way. But definitely good admixtures and other additional materials are available, which will help you to use a good amount of GGBS and even fly ash, and we can match the 24-hour strength or 20-hour strength and things like that. Yes, thank you.
Thank you, sir. The next question asked by Mr. Naresh, and the question is, are there any government policies to identify or label cement as green cement?
Once again.
Are there any government policies to identify or label cement as green cement?
No, this is the problem. So, like, you know, I'm told in other countries there is an encouragement. Forget about the government. The market itself is paying more for purchasing low carbon concrete, geopolymer concrete, and such concretes. Okay, because they have found that all this have a positive impact on the environment, and hence they are ready to pay more and get this kind of good concretes or even good cements. And you know, there are concretes long back done. I'm talking about in 1980s, where they have built hotels with high volume fly ash. One of the examples I can give is 180 kg OPC, 220 kg of fly ash, high volume fly ash concrete for a hotel, where they waited for 90 days strength. So 28 days strength was not considered, 90 days strength was considered. So that is how many other countries are doing actually. And here we need government agencies also to pitch in, where they have to promote green things actually, including labeling and all. Otherwise, a manufacturer can always label based on the available information that it is a green cement or green product or something like that. He can generate data on his own, and then he can label it. But there is no policies at this moment actually. Definitely it will come in future, sooner or later.
Thank you, sir. The next question is it possible to gain 0% cracks in concrete? And that was asked by Mr. Harish S.
So 0% cracks are achievable definitely in a controlled environment in lab. In lab, for example, you maintain a 27 degrees temperature and 90 degrees or 95 degrees humidity, and in this kind of situation, you can able to achieve a 0% crack using SCMs, low water cement ratio, fibers, good admixture, controlled water cement ratio and all. But in field, it is very difficult because the cracks are independent of many times. I can say clearly it is independent of the mix design, but it is more dependent on the external factors like temperature and wind velocity and humidity, and the way you have compacted, how you pumped the concrete, and whether you have provided a shield against wind, or whether you have created a wind tunnel where high velocity winds blow away the surface moisture. So basically the cracks happen when the rate of evaporation of water is more than rate of bleeding. So when the rate of evaporation increases a certain limit, cracks are bound to occur. So it is possible completely to have such kind of concrete if you completely control the rate of evaporation, which is difficult in an external environment. In a large 100 meter cube pore, you cannot control the rate of evaporation because the rate of evaporation is based on several factors, mostly external factors. So in field it is very difficult. You can add too much of good amount of fiber, and you can use evaporation reducers. You can minimize, but you cannot. Nobody can guarantee zero or crack-free concrete on field. In lab it is possible. I hope I answered.
Okay, thank you, sir. The next question is, other than GGBS and fly ash, are there any other materials that can be used in recent days? That is, any newer substituents to achieve better results?
Other than, once again?
Sir, I'll repeat again. Yes, sir. Other than GGBS and fly ash, are there any newer substituents to achieve better results in concrete? And that was asked by Nikita Chauhan.
The other materials which you can use are metakaolin and microsilica, rices cash, but you cannot use those materials in this extent. You can use a huge amount of fly ash, 25%, sorry, 15 to 35%, and in high volume concretes you can use up to 40%, 50%. In other countries they have used 40-50% fly ash. But GGBS you can use up to 70%. Some people have used up to 80% of GGBS. Between 25 to 80%. That amount of material cannot be used. You have copper slag, which is a waste from copper smelting plant, which has to be used lesser, not more than 25-30% or 40%. It cannot match. And then you have red mud, which is which comes from aluminium plant as a waste. So you have other materials like rices cash. If you take rices cash, microsilica, metakaolin, the optimum dosages are between 5 to 12%. So in a way, there is absolutely at this point of time not an exact alternative material to fly ash and GGBS. You can use other industrial weights, like I mentioned. Actually, you have used post-consumer glass powder, which is upscaled glass powder. You can use between 5 to 10% or something, but not in the scale that you can use fly ash and GGBS.
Okay. Thank you, sir. Sir, next we have a question asked by Dr. Sriram, and the question is, what is the significance of slag-based geopolymer concrete? Can it be used as green concrete?
Yeah, slag-based green geopolymer concrete. The first concept initially, the geopolymer concrete was basically fly ash and activators, and then this other materials, GGBS and all, started cropping up. Means started adding in lower percentages. The importance of GGBS in this kind of systems with fly ash and activators is that the GGBS is closer to having more CO. The reactions are faster, and hence you can prepare room temperature cured geopolymer concrete. In that case, GGBS is better useful, and definitely it can be used. It can be used to make low carbon concretes. So geopolymer concretes, most of the geopolymer concretes are can be referred as low carbon concretes, actually, because basically if you're using good amount of fly ash and activators, definitely the total amount of carbon dioxide generated, CO2, including embodied and manufactured, what is used during manufacture is much lesser than reference OPC concrete, and hence can be classified as low carbon concrete. Yeah.
Thank you so much, sir. Sir, that's all with the question answer session, and we are done with that, sir.
Thank you once again for all the audience. On behalf of QCrete for this opportunity, and waiting on this evening until so far, and actively listening to this lecture. Thank you.
Thank you so much, sir. Next, I invite Dr. Elson John for the vote of thanks.
Thank you. Once again, a warm wish to all of you. So today we have an excellent lecture, as always, from Kushaka sir. So he has explained very well in a very nice manner how the concrete can be green, or what is the requirement of the day, because we are using a lot of concrete and that creates a lot of issues in our site or in the construction industry. Especially he was mentioning about the carbon dioxide emissions and all the methods to make the concrete green, and which we have to use or consider while using the concrete is very clearly explained in a very simple way. Thank you very much for being with us and give us a wonderful lecture. Thank you very much, sir. Surely we will have more sessions from you in future also in other areas. I know you have a lot of expertise, and we have to share this expertise to the civil engineering society for the betterment of the construction industry and the nature. Thank you very much, sir. And once again, I am thanking QCrete for joining in hands with the ICI Kochi to dissipate the knowledge among the young budding and practicing engineers. Thank you, Shelly sir, also for that. And once again, thank to VR Kaushika and the QCrete team for this opportunity on behalf of ICI Kochi and all the participants. Thank you, sir.
Thank you.
Thank you, sir. Next, I hand over to Dr. Job Thomas, sir.
Hello, can you hear me?
Yes, sir. Yes, sir. We can hear you.
Good evening, ladies and gentlemen. I am happy to see you all in this auspicious evening. As all of you know, Indian Concrete Institute Kochi Center is very keen in disseminating technical knowledge to civil engineering community, and now we do associate with like-minded organizations to create ready-mix concrete is one among them, and the director of QCrete, engineer VR Kaushika, explained his vast experience about green concrete, and he has given the various cement replacement materials and its effect on the fresh and hardened properties of concrete. And the very important point is that when you use 50% of GGBS, that leads to reducing a carbon emission by about running a car to an extent of 92,000 kilometers. That is very important aspect, because nowadays pollution is very major problem in all over the world, and reduction of carbon emission is a very key concern among among all engineers as well as scientists and all civilians. And with thank you very much for sharing this much knowledge to us, sir. On behalf of ICI Kochi Center, again I extend a sincere gratitude to you, sir. And also I thank Shelly Fernandez, sir, for facilitating the association between the QCrete and ICI Kochi Center. And finally, I thank all the participants for joining with us today for this webinar series. Thank you all.
Once again, thank you to all the office bearers of ICI Kochi Center and to all the participants for spending your valuable time during this evening. We'll come back later with another interesting session. Thank you all. Good night.